This is example 3 for the 8.4 lesson. So we're going to solve the system using elimination, just as we have been doing. So we want to look at our system and realize that adding the equations together right now won't do anything. 3x plus 5x is 8x, 4y plus negative 7y is negative 3y. So nothing eliminates. So we want to multiply one or both of the equations by something so that the coefficients match except one's positive and one's negative. So let's see if we can easily eliminate the x's. So what can I multiply 3 by to make it 5? Well, there is a number that will do that. It's 5/3, but we don't want to mess with fractions, so that's not easy. Same thing, to multiply something by 5 to get the 3 would be 3/5. Again, we don't want to deal with fractions. So the x's don't look easy to eliminate. So let's look at the y's. What can I multiply 4 by to get 7? It's another fraction. Well, what can I multiply 7 by to get 4? Another fraction. So what that means is there's no way to solve this system by multiplying just one of the equations by something. We're going to have to multiply both of the equations by something in order to get those coefficients to match. The reason why it's been pretty easy so far is if you look up like in the previous example 2, we could easily get 2 to become 6 by multiplying by 3. So since 2 was a factor of 6, or you could look at it as 6 is a multiple of 2, we could easily get these to match by multiplying just one of the equations by something. That's not the case down here. 5 is not a factor of 3, or 3 is not a factor of 5. 4 is not a factor of 7, and 7 is not a multiple of 4. So we don't have it that easy for this one. But luckily, it's not too bad. We just have to multiply both equations by something so that the numbers match. So I'm going to show you how to do it two different ways. The first way I'm going to do it is to eliminate the x's. So we want to get these two numbers to be the same, except one is positive and one is negative. So what you have to ask yourself is, what number do both 3 and 5 divide evenly into? And we want to do the smallest one just because it's easier that way. So you should know that 15 is a multiple of both 3 and 5. So we want one of these to be negative 15 and one to be positive 15. So it doesn't matter which one you make positive and which one you make negative. So let's go ahead and take that top equation, and we're going to multiply by 5 to get this to be a positive 15x. So remember, we have to do it to both sides and everything. So I'm just going to stick both sides of that equation. This is equation number 1. And we're going to multiply equation number 1 by 5. So let's distribute. 5 times 3x gives us 15x. So I'm just bringing my equation down here in a nice organized way. Then we have to distribute the 5 to the 4y. So 5 times 4y is 20y equals, don't forget to multiply the right side too. So 112 times 5 is 560. So notice this is equation number 1 still. It just looks a lot bigger because we took the equation and multiplied it by 5. So to each term in both sides. So 15x plus 20y equals 560 is the same as 3x plus 4y equals 112. Okay, now we want to take the second equation and we want that coefficient to be negative 15 so that when we add it to positive 15, they eliminate. So I'm going to do the same steps, except I'm going to multiply this equation by negative 3, because that's what will make this negative 15x, is multiplying the 5x by negative 3. So notice I always tell you that what you do to one side, you have to do to the other. That's in a single equation. We do not have to multiply both equation 1 and 2 by the same number. It's the fact that in a single equation, like equation number 1, you multiply the same number to both sides of the equation. So now we look at equation number 2 separately, and we can choose again whatever number we want as long as we do it to both sides. So that's why I can multiply the top equation by 5, but multiply the bottom equation by negative 3. Just as long as in the same equation you multiply both sides by the same thing. So let's see what we get when we multiply that second equation by negative 3. So negative 3 times 5x, we have to distribute on that left side. So that gives us negative 15x. And then negative 3 times a negative 7y, so be careful there. So negative times negative, that'll cancel out, so it'll be adding a positive. So, and then 3 times 7y is 21y. So again, negative 3 times negative 7y is positive 21y equals, on the right side, we still have to do that multiplication of that constant term times negative 3. So it's negative 114 times negative 3. Again, a negative times a negative will give us a positive. So the answer is positive 342. And that's equation number 2. So notice again that we have two equations that look different, but these are the same as our original two equations. We just scaled them up. We multiplied by a number to make those coefficients bigger. Now we can see the benefits of doing that. Now I can just go ahead and add these two equations together because now they're going to eliminate a variable. So 15x plus a negative 15x, because remember we're doing left side to left side, right side to right side. So negative 15x plus a negative 15x will zero out. And then 20y plus 21y is 41y equals, and then 560 plus 342 is 902. Okay, now we can finish solving because we have an equation that now has only one variable. So we need to divide. Since it's 41 times y, we want to divide by 41 to finish solving. You will need a calculator here. So 902 divided by 41 is 22. So y equals 22. Now again, the rest is just the same thing as you've done before. So really at this step, I could have just let you go because this is what we covered in 8.3. If you're given an equation like this where it's going to cancel out, just add the equations and finish solving. So the only step we added was having to multiply one or both, in this case, of the equations by a number so that we get coefficients that are additive inverses, meaning same number, opposite signs. Let's go ahead and finish solving. Now that I have y is equal to 22, remember I get to choose either of the original equations to plug back in and solve for the second variable. You could even use one of these equations, but please, 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 please don't. First of all, I always tell you to go back and use one of the very original equations in case we messed something up when we multiplied it by a number. So that we made an error here and then it wouldn't work. Also, these numbers are bigger. We don't want to work with bigger numbers than we have to. So let's go ahead and plug that back in then. So I'm going to choose equation number 1. So I'm going to write 3x plus 4, and then instead of y, we plug in 22 equals 112. Let's finish solving. So 4 times 22 is 88. We have to do that first. Now we have a simple two-step equation. So isolate the term with the variable by getting rid of that 88. So minus 88 to both sides. And that gives you zeros out the 88 on the left side. So we get 3x is equal to 112 minus 88 is 24. Divide by 3. And x is equal to 8. Our final step is to check our answer. Since I used equation number 1 to solve for the second variable, I know that 822 works in equation number 1, so you have to check your answer in equation number 2. So when we check, we're going to do 5 times x, but instead of x, we're going to put 8 because that's what we're saying x is equal to. Minus 7y, so minus 7 times our y, which is 22. And is that really equal to negative 114? So following order of operations, do our multiplications first. So 5 times 8 is 40. And then minus 7 times 22 is 154. So it's 40 minus 154. And then I'll just type that in my calculator to make sure it's correct. And yes, it is. It's negative 114. So we confirmed that our answer is correct. So our final answer, we will write as a coordinate point. So x comes first, 8, 22. So that's where those two equations or two lines, if you were to graph them, intersect. And I will just go ahead and put that in solution sets. I will show you a second way to solve this by eliminating the y's, but I will put that in a separate video. So thanks for watching.